Welcome. We are going to be talking through there we go, sorry, this lab, the molar mass of a diprotic acid. And we are doing this is an example of a quantitative lab. So we're gonna take some measurements and do some calculations to try and determine something. In this case, we're gonna determine the molar mass. And this acid we're looking at is diprotic. So let's take a look at what that means. Most of the acids that we discuss are monoprotic, meaning they just contain one ionizable hydrogen. So they just have one hydrogen that they can donate to the solution. Some examples would be like HNO3, HCl. These are monoprotic. Other acids are polyprotic, meaning that they can lose more than one hydrogen ion. Diprotic acids have two ionizable hydrogens. Some examples of that would be like sulfuric acid, H2SO4, and carbonic acid, which is H2CO3. You can also be triprotic. That means you contain three hydrogens that are ionizable, right? And an example would be phosphoric acid, H3PO4. So what we're taking a look at in this lab is we are looking at a diprotic acid, and this diprotic acid is an unknown. We don't know what it is. It could be H2SO3, it could be H2CO3, it could be there's a lot of various diprotic acids out there. We're going to try and figure out what it is. And we are going to titrate it with a solution of sodium hydroxide. So the sodium hydroxide is our known. So we know the concentration of the sodium hydroxide because I made the solution. So we know it's exactly 0.2 molar. And then we're going to figure out how much sodium hydroxide it takes to neutralize our acid. And then if we look at the stoichiometry of this equation, we can see it's a 2-to-1 mole ratio. So there's a 2-to-1 ratio there. So we need 2 moles of sodium hydroxide for every 1 mole of acid. So if we know the volume and the molarity of our sodium hydroxide, we can find how many moles of sodium hydroxide it took to neutralize our acid. And if we can find moles of sodium hydroxide, we can find moles of acid because we know it's a 2-to-1 ratio. And then if we know moles of acid, we can find the molar mass of the acid. And yeah, so I'll just kind of talk through the directions here. So what we are going to do is to find the molar mass. So our end goal is to find the molar mass of the acid, which is in grams per mole. So we need to measure the mass of the acid precisely. So we're going to weigh out a certain amount of acid, record it in our data table, and then we're going to put it in our Erlenmeyer flask, add an indicator to our flask, and then we are going to put some base into our burette. So here's what our setup looks like. Here's our titration setup. In the burette in our lab, it contains 0.2 molar sodium hydroxide. The Erlenmeyer flask down at the bottom contains the unknown diprotic acid. We don't know what it is exactly, so we're just going to call it H2X for our unknown. And we have an indicator in here as well. The indicator we are using is phenolphthalein. And phenolphthalein is clear when the solution is acidic, and it turns pink when the solution turns basic. So the way that we will know that our titration has reached its endpoint is that the solution will stay a very faint pink color. That's what we're looking for our endpoint. And so we'll measure out the mass of our acid, and then we are going to add some indicator, and then we're going to add base until our acid is neutralized. At that point, we're going to know the volume of base, we're going to know the molarity of base, so we can figure out how many moles of base were added. And then again, remember, we know this stoichiometry here, so if we know how many moles of base it took for this reaction to occur, we can figure out how many moles of acid must have been in our flask. And if we know moles of acid, right, so we're going to be able to calculate the moles of acid based on our titration, and then we measured the mass of our acid sample, then we'll be able to figure out what that grams per mole ratio is. So we'll just take our grams of acid and divide it by our moles of acid, and that'll give us the molar mass. So that is our goal there in the end with our calculations. So here is the space for you to, collect data. For those of you who are doing this virtually, I'm going to make a separate video going through this data collection. And then here's some hints here again at the bottom of what your calculation, steps are going to be. All right. So that's it. Thank you for following along. Yeah.